This week we are working on attributes of triangles and quadrilaterals. And for Monday's lesson, we're working on triangles. So attributes is the ways that we describe triangles, things about the triangles that we use to talk about them. And a lot of this is sort of review of vocabulary and also maybe some new vocabulary that you haven't heard before. But even if it seems like it's kind of a lot, I think you'll find that it's similar when we talk about quadrilaterals. And so you're taking in information that's going to be useful for both lessons this week. So we're going to start with triangles. And sometimes I just draw a little triangle to mean triangles so I don't have to write every word out. But we're going to start with the triangle. It's a closed shape. That means that all those lines touch each other. And it has three sides, 1, 2, 3, and it has three angles, 1, 2, 3. And the angles of a triangle always add up to 180 degrees. So there's going to be some problems that we need to solve, and they're kind of mystery problems where you have to figure things out. And you just need to know the angles in a triangle all add up to 180 degrees. So let's talk for a minute about some vocabulary around types of triangles. And one type of triangle is an equilateral triangle. And that means that all three sides are the same exact length and all three angles are the same exact size. So all sides are equal, all angles are equal. And the thing that helps me remember on equilateral triangles is the equa part. They're all equal. Isosceles is our next kind of triangle. An isosceles triangle has two sides that are the same and two angles that are the same. So where the two sides meet, that angle is different, the two equal sides, but the two sides where they meet the third side, that angle is the same. So two sides are equal, two angles are equal. And isosceles has an S that says the S sound and a C that says the C sound. So I think about that when I think about two. Or you could say there's two S's in isosceles. That's another way. Isosceles, isosceles. Okay. The third kind of triangle is a scalene triangle. And scalene means nothing is the same. None of the sides are the same. None of the angles are the same. Now, if you look closely at my chart here, you can see that there's some markings. So when mathematicians put one line on a side, they're telling you that side is the same as any other side that has that one line on it. So in an equilateral triangle, you could put a little line on all three sides because they're all three the same. In an isosceles triangle, that little line means that these are the two sides that are the same. And an isosceles triangle can also be like this, where the two sides that are the same are in a different position. But that doesn't change that angles where it meets the third side are the ones that are the same. Okay, then scalene has no sides, so there's no markings on it. And then this also works for angles. They use a little curved sign that's in the middle of the angle to tell that those are the angles that are the same measurement. So in an equilateral triangle, all three of the angles get a little curve to show you they're all three the same. In an isosceles, just two of them are the same, so just two get the curve. And in a scalene, nothing is the same, so no curves are happening at all. So one line means it's equal, and you can look at any time there's one line, all of those one line marks are the same. And then same with one curve across an angle, anything that has that same one curve, they're equal. Okay, so now we're going to keep going. A right angle is a 90-degree angle. And oftentimes we show that by putting a little box in the corner. And if you don't have a ruler, a way that you can find out if it is a right triangle is to stick a piece of paper in the corner. And if it matches up perfectly, which if I was perfect at drawing, it would match up perfectly, then you know it's a 90-degree angle. And if it doesn't match up, like in this one, if I line up one side of my angle, there's no way I can even see that other line, so it doesn't match up. It's not. So a right angle means it's 90 degrees. A right triangle means there is one 90-degree angle exactly in that triangle. Only one, because if the angles add up to 90 or to 180 degrees and you had 3 right angles in there, it wouldn't close into a 3-sided shape, and it definitely wouldn't add up to 90 degrees. So you can only have one 90-degree angle in a triangle. And you can also have an acute angle. And acute angle is smaller than 90 degrees. And if you have a triangle that has all 3 angles are acute, meaning smaller than 90 degrees, then you have an acute triangle. And the way that I remember acute is smaller is inside of the word acute is cute. And I say, oh, a cute little baby angle. And then I say, oh, a cute little triangle with all baby angles. And it's kind of goofy, but it's the way I remember. And then the last kind of triangle that we can have is an obtuse triangle. And obtuse means larger than 90 degrees. And obtuse is another one where you can only have one obtuse angle in your triangle because it's more than 90 degrees. And if you had 2 of them that were more than 90 degrees, you would end up with no room for the third angle. So it doesn't work. So these are the names of our kinds of triangles, and these are the markings. And if you are having trouble with that, just freeze your screen on this chart so that you can look back at it. Or I did attach a little chart that might be helpful in the documents that just has the information about triangles and quadrilaterals. So that might be useful instead. Okay, so let's get down to business. In our lesson on Monday, you have 2 kinds of problems. One just asks you to identify all of those kinds of triangles. And that seems pretty straightforward to me. Use the chart, remind yourself of what those things mean, you'll be fine. But then sometimes you have these mystery problems, and it will say to you, shade in all of the acute triangles or something like that. And then sometimes they give you measurements. So when they give you measurements, I just want to show you what you could do with those. So if we know that a triangle always, the angles add up to 180 degrees, then what you can do here, sometimes you'll get a little box, and we know that box means 90 degrees. So sometimes you get a box plus a measurement, and what you can do is you can add them together, and then you can subtract them from 180, 113, and that will tell you the measurement for the missing angle. So here we have 1 from 7 is 6, so this angle must be 67 degrees. And then if it's asking you if this triangle is isosceles, you could say no, because these 2 angles are not equal. Or if it's asking you if this is a right triangle, you could say yes, because it has that little box in it. So there's one of them. Here's another one. This one's definitely not drawn to scale. I just made a triangle and then I put the measurements in. But sometimes it will give you a problem like this where it will say, what kind of triangle is this? And you have to add up the triangle measurement, the angle measurements, and then you have to subtract them from 180. And when you do that, you find out that this third angle has to be 36 degrees. And as soon as you find out that that has to be 36 degrees, then you know 2 equal angles is going to mean isosceles. So this one is isosceles, this one is right, and And now we're down here. And this last one, this one could be tricky because it says there's two that are equal. So you might say to yourself, oh, if there's two that are equal, that's isosceles. But it isn't actually, because if you do 60 plus 60, you get 120. If you subtract 120 from 180, you get 60. So this guy is actually equilateral. So I don't have a ton of examples here, but I'm happy to work on examples or problems with you if you come to a math meeting. And otherwise, I think that you can use the information from the chart here to help you. And like I said, I sent one of these, but you can also just look up online and say triangles and look at the visuals, like images, and you can usually find this chart also. All right, good luck with those triangles. Get out there and identify everybody properly. Have a good day. Bye.